Hello. Good morning, good evening, good afternoon from whichever part of the world you are. Am I audible to everyone? Can I please have a show of hands, please? All right. That seems to be working perfectly. So once again, smarter SnapFit design using FEA. How to design a better SnapFit device using the capabilities of FEA to help you. Let's get started. First, more about myself. I'm Vikrant Srivastava. I'm an FEA applications engineer working at SimScale. I have a master's degree from RWTH Aachen University, and I have worked previously for structural analysis with thermal simulations and with nonlinear design. And let's get started right onto it. Why should you care about CAE? Why and what can you do with this thing? You should always and you would always have multiple design objectives and constraints while deciding what to do for your manufacturing project. And if you're manufacturing anything anything at all at this point in time, I think you should be learning how to do it very, very well. Now these constraints can be aesthetics constraint, which are sometimes very, very important. And if you look at it, the best-selling products, the Teslas, the iPhones, they are popular not just because they work, but they're popular because of how they look. And this look is very, very important to many of the customers. It becomes a style statement, it becomes a lifestyle statement at times. The device or the body should always, and that is one of the biggest points, have its functionality. All purposes of the device should be fulfilled by the design of the device itself. It should be cost efficient. You cannot be wasting too much money making the same product over and over again. It should be durable. It should not break as soon as you make it. Safety is of paramount importance, both if it's of the device, if it falls down, it should not break, but more importantly, if it deals with real humans. For example, you can look at a helmet here, how it would impact a body, what stress would impact on your head if you have a helmet or if you don't. And that sort of shows you, how safe you can be. And using these data, using these materials, you can analyze your design, you can make better design choices, you can change whatever is required to make sure that your design is very, very safe. And of course, at times you go through certifications. And these certifications, they depend on the market, they depend on where you are, which country you are. So a design certification of USA might not work in Europe. One that works in Europe might not work in China. And then you always have to make sure that your certifications are fulfilled. So it depends on your government and the criteria of the market and in general the market by itself. There can be many, many, many more such design objectives that you have, and you should always focus on the ones that are most important to you. This once again is a very subjective thing and you cannot decide it based purely on your intention, but the more you look into it, the better it becomes. That's how designs work. Now aesthetics is something that an engineer or a developer cannot design very well by himself, and it depends on person to person. It's always a subjective thing, but the rest of these things you can always do with CAE. So why should you care about simulation? Once again, this is a normal manufacturing procedure. You first make a design. Once you have the design, you make a physical prototype out of it. This physical prototype can then be used for testing. So you perform some tests on the physical prototypes, and once you have done your tests, you get your results and you make those design decisions based on those results. Once again, you redesign the body, you go back to making a physical prototype, you test it again, you redesign it again, and then this iterative cycle keeps on happening till you reach a point where you finally decided a completed finished product and you build it. How can simulation change this? This is much more faster, it's easier, it's much cheaper. If you see here, once you have made your CAD design, you can go ahead and create a simulation out of it. Now the simulation takes away the need of making a final design. What you can do is, instead of having one final design, you can simply iterate the designs right there in your simulation, in your software. So you are not making costly prototypes, or you're not waiting for months or sometimes hours or weeks maybe at times if the prototypes are not readily available, and you make those testings and redesign features happen right here inside the software, which saves you a lot of working time. It saves you a lot of cost of getting the prototype ready, testing the prototypes, buying the machines for testing the prototypes, and then finally building your end product. And I would like to, tell a personal story that I read a few years ago that I really connected to. NASA was doing research to cut airline fuel in half, and they were trying to cut, obviously making better design parameters, having lesser pollution by 75%, bring noise levels down by 1/8 of it what it was. And this would have saved the airlines in approximately next 25 years if this one design change was made. It would save the airlines a total of 255 billion over the next 25 years. And it was just the load on the wing and how it moves along. So, design the wing better to make sure that the simulation, the end result is better. And they started with not perfect knowledge. No one has perfect knowledge, but they went along with it and they decided to have many iterative products. And ultimately, they were using thousands and millions of dollars in trying to design this. And hence, they figured out they have to go to a faster and a better way. They ended up deciding to simulate this product. And they were able to simulate it. And at the end, they saved billions, literally billions of taxpayer money, as well as billions of money for the future customers. And it helped everyone. So once again, how and why should you care about CAE simulation? As you can see here, the cost of design changes. As time goes on, it rises exponentially. So if you make your design changes starting in the product, it's very, very well. If you make it later in the design process, the rates rise drastically. And also, at the starting of the product launch cycle, you have a lot more design options. These design options, they keep going down as the time reaches more towards the product launch time. And how to make this better? Now, better, once again, is very subjective and it depends on your focus. It can be lower cost. You might require lower failure risk. You might want lower weight of the body or an increased product lifetime. You might want to increase the performance of your product. And there can be many, many other such considerations that you might have. In all of this, because the time being the critical factor here decreases for iterative design changes, you ultimately end up with a much, much cheaper product being made much faster and with much, much better design parameters. Let's go on. Now that you know why to care about simulation in general, I would like to tell you why to care about SimScale, simulation with SimScale. Now, the biggest problem for most people is that design softwares are very, very expensive and they're not easily accessible. You need to first buy the license or download the software and then get the licenses to it. And then you need to make sure that your computer is really, really fast. Because with slower RAM, the total time that you waste on making a product run is much, much higher. SimScale solves this. All you need is a workable computer that can open a standard web browser, Google Chrome, Microsoft Edge, Mozilla Firefox, something like that. And then you're not using a high-end machine at your end. The calculation is happening at the supercomputer is here at SimScale. So your calculations are much faster. You can decide how much RAM or how much memory you want to have, and you can have a much faster simulation, much cost efficient. You don't waste as much money trying to do everything. But one more consideration is you have to learn the software, and learning the software is always a big issue because the knowledge transfer is not very easy. It takes time and effort. How you can do this with SimScale is you can simply go to the SimScale website, and we have thousands and thousands of free public projects. So if you're a paying customer, you can always have your projects private. But if you're a free customer, if you don't want to pay and you just want to learn initially or even at a later stage of your subscription, what you can do is you can make public designs, and all designs that you make if you're a student or if you have a free account are public. And these designs can directly be copied at the click of one button. And you can see exactly what another designer or other students or other companies did to make their simulation run. And that makes the learning process very simple. And at times, because we have thousands and thousands of public projects, what you can do is if you have a design and you know your CAD is similar to some other CAD, but different in a small way, you can evaluate your own CAD by basically copying the older simulation and manually copying each of the steps that the older simulations have done. And most importantly, it's for everyone. So we have a very large public project library, but we also have live chat support. And this is something that you might not find in many softwares right now. What we help you is while you are designing right there on your software in the browser, because we are completely cloud-based, you can contact us anytime. So you don't write us an email, you don't wait for us to respond to you. You just write us while designing. You give us the permission to view your project. We look at it. We tell you what you're doing correct. How can you improve it? And it's one of the fastest ways to learn that I have seen. You don't waste time. You don't waste effort. You just do your simulation right then and there. Along with that, we also offer free training material, and there's a lot of training material that can help you become a better designer in general. And I really advise that you go ahead and check it out. Once again, the methodology of a simulation: you import a CAD as with every other simulation software. This can be a step file, a IGS file. We have a partnership with Onshape. It's one of SolidWorks online browser, and you can use it to directly import a CAD without even uploading it. We do the simulation. We go through the normal setups. We set up the mesh, we set up the boundary conditions, and once we are done with it, we get the results based on which we make the design decisions. And because it's all happening on the cloud and because it's happening fast enough, you don't have to waste time waiting for it. You learn faster and you don't make too many mistakes because we are right there always to help you with the chat. We also help you do many different types of analysis right in that one computer. So you can do a static stress analysis. If you're doing a transient analysis, then you can perform a dynamic analysis. For example, as you can see here, a mobile phone falling on the floor. You can check the thermal stresses on a body of yours, and you can even do harmonic vibrations. Now these all are FEA simulations, but you can also provide and go ahead with CFD simulations. So we have fluid dynamics simulations right there. We also have particle simulation where you can see how to mix different things or different materials and how it happens, how you can perform it together. Once again, we have more than 40,000 template simulation products. These projects can directly be copied at the click of one button, and you can reuse it, which speeds up your total simulation time drastically. Now, getting to snap fit. What exactly is snap fit? Why should you care about snap fit? Where is it found? Snap fit is one of the simplest mechanisms to join two bodies together. You can find it everywhere because it's very, very cheap and it's very, very secure. You can find it in mobile phones, in containers, in belt buckles, toys, keyboards, helmet joints, and many, many, many other products. It can be of different types. You can have a shape like this U, you can have a cantilever, you can have a pendulum design. It depends basically on your perspective and your need. Why do you need to simulate it if it's there everywhere? Why do you need to make sure that you have a properly designed body? Once again, because the experiment with the snap fit will take you time, it will take a lot of money, you have to spend a lot of energy, and you have to buy specialized testing apparatus. Also, even if you have all of these things with you, you might miss something small. Your snap, as you can see in this body, has a very high stress factor here, and you might make the design changes to reduce it from here, but you just might miss this part or this tiny little part here, which might cause you ultimately to not be able to do your simulation properly, or your product might fail much earlier if you have not simulated it properly. And once again, you'll be wasting a lot of time just designing it and making the analysis, and it's important for a designer as well for a manufacturer to go to the market as soon as possible. So for a snap fit, what do you need to know? You need to know the design parameters. You need to know what material are you using. Is it stiff? Is it light? If you're using plastic, if you're using steel, and this depends on the application for which you'll be using it. For a small tire, you can always have plastics. If you're planning to join two huge bodies together by snap, you will need a much more stiffer material. You will need to know the shape of the cross section. This is the cross section here shown by the little H. You can see this can be constant throughout the body like this, a square, or this can be varying, and this causes a lot of difference in the stress over the body. So it results in drastically different end products. These cross sections can also be a U shape or a torsion shape or an annular snap joint. You also have to think about this taper radius R. The taper radius is also very, very important while you decide the use of your snap, because this taper radius will determine the stress forces on the head of the snap, the point where the snapping head joins to the rest of the body. You need to know what mating forces you want. In most cases, you want a smaller snap force. You want to go in easily enough. But if you want a different or a more complex simulation, you also need to focus on your unsnap force. If you want something to be airtight, you must ensure that it doesn't open easily, and you want a higher unsnapping force. If you go on about reducing impact, if you have a mobile that falls down, you have to make sure that it doesn't break open, and you have to make sure that the stresses deliver much faster. So for reducing impact, you want ideally lower unsnap forces. So you need to make sure that you understand the cross section, the taper radius very, very well. The ratio of the cross section to taper is